Okay, so problem number 34, question number for the 22 test. It's the same thing we did a little while ago. We're up here and we're going to use the representations here to model sum for a variable. Again, all the only difference here is how they look. But this is 1, 2, 3, 4, 5x, 1, 2, 3, 4, right? So 5x plus 4 equals, I think it's 10 on this side. If we bring out and actually use the concrete models and then go into pictorial into abstract, our students should be able to just go picture abstract. But we have to bring out those manipulatives first. If you skip this, we're going to continue doing this 34% the state, or 60% for us, right? So we always beat the state, and we should do better in state. But again, we're at 6 out of 10 kids again. 6 out of 10 of our students can do this. So we still got to reach 4 more kids, right? Or in this case, 42 more kids out of 100. Let's bring, I think we can hit in the 80s, to be honest with you, on this one. So if our kids get good at using, for example, tiles, right? Algebra tiles. And I'm going to click this guy open. We'll be fine. I can use the tiles. I can represent this and then get an answer. So I'm going to do that. I got 1, 2, 3, 4, 5x. So let's go ahead and model that. 5x. And yes, I'm using algebra tiles. 5x. Okay. And then over here, then we got 1, 2, 3, 4. 2, 3, 4. My line's my equal sign. 10. There you go. And so let's go to this guy here. And I highlight over it and I go copy, and that's 10. I'm going to see if I can slow it down because a lot of times it skips on me. And that's what I got here. I got 5x plus 4 equals 10. I can remove already where I want to right now these 4 and then remove 4 on this side. But we don't do that. I'm going to make a copy. I'm going to bring it down and I'm going to negate it. I'm going to make it the opposite. When I do to one side, do the other because we're keeping the weight balance on both sides. So these 4 will cancel. And then these 4 will cancel out. I canceled out this side. All right? And so I got 5x equals to 1, 2, 3, 4, 5, 6. Once our kids get really good at solving for a letter, they'll understand that all this is 6 over 5. They'll be able to kind of understand that whatever this number is on top, whatever the x value has, it should go in the bottom. So at some point, we will get to this part of problem solving with the tiles. So my students will physically grab the tiles and then move the line. This is what they'll do. They'll grab this line. They'll move it like that. They'll grab these guys over here. They'll put them over here on top. They'll grab these x's over here and they'll put them here in the bottom. 1, 2, 3, 4, 5. 6 divided by the 5, right? And yes, I have to fix them because they'll tell me this 6 over 5x or 6 over 5x or written this way. Yes, that's what you wrote, but it's really x equals 6 over 5. Gotta explain to them why this works. But it's really neat when they start getting like really savvy with those manipulatives, man, and it's wonderful to watch. Okay, but in the meantime, what we really want them to be doing is this. Okay, I got 1, 2. I'm going to get rid of this. Delete that. Delete that. Let's move this guy over. Is that I got 5x. I got 5 people with 16s, and I got to distribute equally. So you get 1, you get 1, you get 1, you get 1, and you get 1. If you're a student watching this, this little move I did over here is kind of neat, right? So I got this guy left. I got 1 and then something. I have a hole here. I'm gonna kind of use a picture to represent him. So I got the number 1 right here, right? This is number 1. And I got to share it with 5 different things. So it's 1, 2, 3, 4, 5. You already know what the heck's he doing. I'm going to cut this guy into little parts that are what? 1/5. 1/5. 1/5. 1/5. If I wanted to, I could have grabbed the fraction circle and brought out the 1 here. All right? Get it? It's still 1. And then just split it into 5 parts, and each one, if I split this guy, will get a 5th. All right, and so then my answer becomes x equals 1 and 1/5. I'm trying to get this guy going here. Come on, pen. Here, and 1/5, which equals to 6 over 5. Get it? Because then I could grab this guy and say, well, what is this guy really? So this is my 1/5 here. I'm gonna grab everybody here and just kind of move everything out of the way, so you can kind of see what I'm doing with actual manipulatives, right? I'm a manipulative guy. I love manipulatives, right? So there's my 1/5, and then this guy can use what instead? The 1, right? So it's 1 and 1/5. So that's what x equals to, and then say, look, to get that 6/5, all I did was cut them into that 1, 2, 3, 4, 5, 6 fifths. There's your connection with the concrete objects, fraction circles, to my symbolic answer at the end, which is 6/5, which is right here. And this is where we're at right now. We bring out the concrete models, and this all takes care of itself. If when we decide to do this, our students can immediately just do this. These 4 are gone. These 4 are gone. I have 6 here. I got that 5x here. Getting used to that this side will be divided by this side. They'll see this already and give me this answer at the bat. That's when they conceptually get it. In the meantime, I can do my circles, or I can do my x, 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 and x. Draw my line. You get a triangle, which is u, 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 and u, and u. That's the 5. 1, 2, 3, 4, 5. U I cut into fifths, and so on, right, etc., all the way down. And I got x equal to 1 and 1/5, which is my 6/5. What does that look like when we finally ask you to solve it? It looks like this. -4 on both sides. There was my -4 on both sides. -4 on both sides. When I did the work over here, the same thing. 5x equals to 6. You divide by 5. There's your answer. We do the concrete, we do the picture, go to the abstract. This number goes into the 80s or 90s, guaranteed, guys. So, not hard to do, easy stuff. Use the tiles, please.